Welcome back. We're going to try again. I know we had some technical issues, so we'll just do this version. First thing, I have indeed taken a look at your projects, and I'm in the midst of grading them as we speak, so I'll be looking forward to seeing the high-low. It's almost done, and then the crypto is coming up. So we're going to take a look today at how to build graphic user interfaces. And that's a pretty useful thing to know how to do. Make sure we're sharing this. Okay, good. That's a pretty useful thing to know how to use because, of course, so far our programs have all been on the command line. And that's great, but of course you're used to programs that have things like buttons and windows and stuff like that. So that's what we're going to do today, is create programs that have those features. Well, let's begin by looking at our first program. We're going to use an interface system called Swing. And this was Java's second attempt at a GUI system. The basic idea is, of course, a GUI is based on the local operating system's GUI. And so if you're running Windows, you'll see things differently than if you're running a Mac or a Linux machine. And so the real question is, how does a multi-platform language like Java support multiple user interfaces? And there's a couple of solutions. There's an older one called Aught, which was very clever, but had some pretty big limitations. Now, then there was another approach called Swing, which is the one we're going to use, which actually is quite powerful. Now, there are some newer techniques that are being used, but Swing is reasonably typical, and so you should get a good sense of exactly what's happening. So let's take a look at our first program written in Swing and see if we can understand what it's doing. So there, we run it, and it's right over there. It's not a very big user interface, but look at that. We have a little window, and it does the things that a window should do. Now, what's interesting, I'm running on a Mac, so it looks like a Mac window. If you run this on your Windows or Linux box, you'll see it look like that operating system. Notice the little red X of closiness. I click on it, and it closes the thing. Okay, so that's nice. Let's take a look at how we do that. First of all, we extend Jframe. That's really the key to everything. And the reason I was talking about object-oriented programming so much last time is that objects are the key to graphic user interfaces and many other kinds of programming. How do we make a Jframe? Well, we extend it. We don't make a Jframe. We make something based on Jframe. Remember when we talked about the police Lamborghini, right? How do you build a police Lamborghini? Well, you start with a Jframe. How do we make, or with a Lamborghini, how do you make a hello swing? We start with a Jframe. And that's what we're doing. Now, when we run this thing, all we're going to do in main is new hello swing, and my constructor here just sets a few things up. Now, what's happening here? The first line of this constructor is super hello world. What does that mean? Well, that means build my parent class. You know, if I'm a police Lamborghini, this line would be make a Lamborghini. And so this is calling the parent class's constructor, and when we look it up, as we will soon, you'll see that we can, the Jframe class can take a single string as a constructor, and that will become the title. Oh, that's nice. Okay, so now line 25 looks terrifying. This .set default close operation hello swing .exit on close. Yikes, that is very verbose. There's a lot of words there. I agree. So what's happening? It turns out it's relatively straightforward. It is wordy, but it tells you exactly what's going on. Well, and what's happening is this. Okay, when I run this thing again and we look at the little window, right? It's pretty obvious what that guy does. It's pretty obvious what that guy does. What that guy does actually is not so obvious. And the reason is it's possible for a program to have more than one window open. And so this X might close the current window, or it might close the entire program. And it's not obvious what it should do. Well, what do we want? We want the X to close the entire program. And so that's what this line does. It says, hey, when the user tries to close it, however the operating system says you can do that, what I really want to do is exit. There are other options we can look up, and I'll show you where to find those. But we're saying, hey, I really want you to close this son of a gun when I say close. That's really what I'm looking for right now. Okay, that makes some sense, right? Sure, it does. All right, so this is saying, hey, close it the way I want you to close it. And almost always we'll use this. Okay, so now what's going on? Well, the container, or the thing that we're building, let's run it again, it's not called a window because Microsoft wouldn't let Java call it that. So it's called a frame, technically a Jframe. Now the Jframe has this title bar area, that's kind of by default, and then it has this area. And the key thing about this area is we can put stuff there. That's where we can attach things. And so there is a method called this.getContentPane. And what that does is that allows us to have access to this area where we can actually place our objects. So we're going to put a bunch of other things here, drop-down lists and buttons and labels and text boxes and all that kind of stuff is going to go there eventually. All right, so the this.getContentPane gives me access to this container, which I'm calling now surface, and I'm going to be able to add some things to that. Okay, so what am I going to add to it? Well, how about this? How about I add a new Jlabel? Now you're probably figuring this out. The swing things all begin with J. So there's a Jframe and a Jlabel, and there'll be a J button and a J list box and all that sort of stuff. Okay, so the Jlabel is, well, it's a label. So I can put some text there, and I can give it a default value. Hello world. Well, that's nice. Yeah, it is very nice. Now, the next thing I need to do is somehow set the size. Here, I'm gonna take this one line out for a moment so you can see some interesting things that might happen. First, I'll just run it like that. So I'm gonna save it, I'm gonna compile it, and I'm gonna run it. And there it is. Oh my goodness, it is tiny. You can't even tell that there's something there. There is, but it's so small I couldn't see it without resizing it. Well, that's not good, right? Okay, true. So what I need to do is one way or another, I need to set the size. Java doesn't automatically set the size. Now this .pack, what that does is it makes it as small as it can, and oh, sorry, got to recompile. Hold on, compile, now rerun. That's still small, but at least I can see hello world. It turns out we could do this instead. We could say this.setSize 200 by 400. See what that does. Compile, run. Now it makes it really tall. Oh, okay, we could change it again. We could make it 400 by 200. Now, how do I know these things? Of course, I looked it up in the online documentation. We'll spend some quality time there in a minute. But now we want to take a look and see, okay, so that makes sense. That makes sense. All right, cool. So can you agree that, all right, we would want to set the size? Yes. Now, this one is interesting because if I don't have this line down here, set visible, we can compile it, and we can run it, and it is running. But what do you see? Well, you see nothing. And that seems very strange. Why in the world would we go through all the trouble of creating this thing and not show it? Well, it turns out there's actually a very good reason for this. Many of your programs will have multiple forms or windows on them. And so we don't usually want to show them all at the beginning, but we often do like to create them all at the beginning. You know, when users are loading up their program, they're used to waiting a little bit. And what you're doing is setting up as much as you possibly can during the initial setup so that while the user is working, they don't feel the slowdowns. So a lot of times what we'll do is we'll create all of our frames at the very beginning of the program, but set them all invisible except the one we want the user to see. So we have to explicitly set the size either with the pack method or the set size method, and we have to explicitly make it visible. So let's run this and see how it's working now. Okay, it is a reasonable size and it is visible. So that's nice. Yeah, that's pretty great. So there is our basic hello world as a GUI. Now let's make one slightly fancier. And I'm going to show it to you so it looks better, but then we'll come back and figure out how we would do the code, because that's an interesting problem. So we'll compile this guy and we'll run it. What up? Okay, that's pretty now. Okay, I know it's hard to read that. We can change the color. But what has changed here? Well, a lot of things have changed. One thing is we've got a background color. Another thing is we've got a foreground color. Another thing is we've changed the font size. We've centered the label. We've done a lot of things here. So clearly there's a lot happening here that wasn't happening before. And the real question is, how do we get it to do these things, right? I mean, I could just tell you, but the truth is you're probably going to want to do things that I haven't thought of. So what we need to do is we need to look in the documentation a little bit and make sure we understand what new libraries we're dealing with and how we get around them, and how this has everything to do with object-oriented programming and inheritance and all those sorts of things. So let's go to the Java docs for Swing. Okay. All right, so we are in, when we go, let's look at the whole deal. Remember, we were in the Java docs, and here's a bunch of really interesting packages. Now, here's one called aught. Remember, I mentioned aught. Aught is not something we use anymore, except there are still some useful things that aught uses, that Swing uses parts of aught sometimes. So you'll still sometimes run across aught, even though that isn't the main GUI we're using anymore. As we look through all the packages, you come on down here and you'll see javax.swing. It's way down here. javax.swing, and that contains these visual components. You look at javax.swing and it's kind of intense. There's a lot going on, but don't panic. What are we looking for? Well, these things that begin with J. And the first one we want is the Jframe. That's what we've made. So let's take a look at the Jframe and see what that does for us. First thing you'll note about the Jframe is that it has a long family tree. Its daddy is the frame, and its grandpa is the windows, and great-grandpa is container, then component, then object. So it can have more than one ancestor. Yes, it can. And it gets something from each of these ancestors. And that's really, really important, because that means that the frame itself, the Jframe object, has certain characteristics, but it also gets characteristics from the java.aught.frame, which gets things from the java.aught.window, and so on. Okay, that makes sense. So let's take a look at some of the things it does. The first thing we'll look at is its constructors. Okay, it has a no parameter constructor. Great, makes a new frame that's initially invisible. We knew that. Here's another version, a new initially invisible frame with the specified title. Hey, we've seen that too. Okay, and there's others, but this is perfectly fine. Then we look at its methods, and it has a bunch of methods. And as you look at it, most of these we don't care yet. Get default close operation, that's interesting. That's the one we've used to determine what happens when they hit the little red X of closiness. There's a bunch of other things we may or may not understand right now. But now take a look at all of these things. Holy moly. These are the things that are defined by frame. Well, by Jframe. The Jframe doesn't really have that much going on, but it inherits a whole bunch from its daddy class. And it inherits even more from its grandpa class, and even more from its great-grandpa and great-great-grandpa. Well, why does that matter? Well, that matters because this shows that inheritance gives us some extreme power. Okay, let me show you another way. So we have this thing going, and when we run it, you can see that we have changed some things. So one of the interesting things I want to know is, how did I change what the label, right? We want to change something in the label. Should we look up label? Maybe I changed something in the frame too, right? So I may have changed something in Jframe. I may have changed something in the label. Let's talk about the background color. How do we change the background color of a Jframe? I think that's a fair question, right? And what would you expect to find in the Jframe? Well, I would look for something that's like a set background color, right? Set background, set color, set background color, something like that. And as we look through the Jframe documentation, you'll see that it doesn't have that. I look at all its methods, and there is not a set background color. There's set content pane, there's set JMenu bar, but there's not a set background color. Well, that's problematic, isn't it? Yeah, but if I do a little bit of a search here, okay, and I start to look around. In fact, I could just do it through the search method of my screen, right? Find color. Ooh, that's interesting. Get color model. Let's see if we can do a search for background. Okay. Set background. Interesting. I wonder what set background does. Oh, okay, there's get background, there's set background. It sets the background color. That's interesting, but notice something else interesting. When I look up here, I am no longer in the Jframe. I'm in the window. What? Okay, let me show you what happened. Set background is actually not defined by the Jframe. But then we look at its family tree to say where it may be. Is it in frame? No, it turns out it isn't. Is it in window? And yes, it turns out it is, in this case, in window, I think. And you can look and find it in these. You can look around and see where all these various things are. So set background, let's see where I found it again. We'll do a search. Background. Okay, we can see set background came from frame. Interesting. It also was in window. And there's something slightly like it in component. So when we look at frame, maybe we could see what set background does. And because this is derived, the Jframe is derived from frame, it has the behavior of the frame. Just like when a police Lamborghini is derived from a Lamborghini, it still has the really powerful engine. So this looks a little bit scary, but it turns out, all right, let's go find that set background color. Set background. We may have to search again to find it. Set background. Hey, that looks great. That sets the background color of this window. So when I set the background, it takes a color called BG color. Okay, that's great, but what is color? Well, we'll dig around again and we'll find out what a color is. Everything in Java is a class, unless it's primitives like integers and floats and so on. And so it turns out there is an object to represent color. And it's kind of complicated, but here's the good news. There's a lot of built-in constants. So we could do color.yellow. Oh, we can also do some really cool stuff where we can use RGB or HSV color models and so on, and we can do interesting things, but for now we'll just go with the defaults. Okay, let's take a look and see what happened here. Actually, I didn't change the color on the object, I changed it on the label, and we'll see what happens. Did I change it on the frame at all? No. Okay, so we could look at the label object and see, is there a color changer on the label object? All right, let's back up a little bit. Let's get in our Jlabel and let's take a look at it. Maybe we should have the ability to change the color, the font name, the font size, all those things. Let's see if we have it. Excuse me. All right, so we're looking around and we see the Jlabel, and once again, it has a relatively small number of constructors. We can send it some text, and it has a relatively small number of methods, but it does not have a set background or a set foreground. Oh dear, but do those exist somewhere? Yeah, turns out right there, it inherits that from something called JComponent. Oh, that's interesting. And the set background, we pass it a color. Oh, hey, while we're at it, there's a set font. Okay, so now let's take a look at this and see what we have done here. I'm going to take that out for now because it's a little confusing. Okay, so let's take a look at this version of the program that's a little more sophisticated. So we're still going to create a Jframe. You can see that I've extended Jframe. This I'm going to just not worry about for now. Now, I'm going to get a container. This is what I'm going to hang things on. Now, when I build a new Jlabel, I can give it some text. And when I looked at the Jlabel, there was another thing I could do that could say whether it was centered. And so I'm going to pass this constant, swing constants.center, and that's going to make it centered. Oh, how did I know that? I looked it up. That's how I knew it. Now in the Jlabel, I'm going to set the background. And how did I know that? Well, I looked in the documentation. And what color do I want to make it? Well, let's make it yellow, color.yellow. Now I'm going to set the foreground, color.pink or color.red. Let's make it more obvious because that was hard to read. And then we'll try this thing and see what it does. Now, how about the font? Well, there's a set font command. And the set font, well, set font, font. Yeah, that's redundant. So what should I do? Well, I should drill down and look at what the font class is and look at its constructor. How do I build a font? You look down here and you'll see, oh, we can do a font that has a string with a name, an int style, and an int size. The style and size, well, those are going to be these constants here. Oh, you may have to play around to get it to do exactly what you want, but you take a look and all of this is starting to make sense. Label output, set your color to yellow, set your foreground color to red. Set your font to a serif font, which is italic, bold, and 40 points-ish. Actually, we don't really know the font size of things on a screen. Remember, your screen sizes may vary. We're going to set our size to something. We're set visibility. Now, one more thing we have to do is just building the label does not attach it. We have to use the add method to attach it to that surface we got in get content pane. So we create the surface, and then we add the label to that surface that makes it visible. And so now we should see red text on a yellow background on our label on our Jframe. Okay, we should see that, but we won't. Okay, run. Okay, are we feeling good? It's centered, it's a larger font, it's italic, it's got serifs, it's red. What are we missing? Oh, yellow background. The yellow background is not there. And the reason for this is actually kind of cool, but a little bit frustrating. And that is when you think about it, labels don't always have a background color. A lot of times we want labels to just look like they're floating on top of whatever the background is. So by default, labels do not display their background color. They display whatever was underneath. And so, you know, I can prove this by setting, let's set the main pane, this dot set background color dot green. Now the main object's background color will be green. And so let's see if the background is green. Okay, compile, run. And so we have, we had a temporarily green Jframe. That's interesting. Let's run it again. It was green at first, and then it turned white. Well, that's not fun. Right. So what do we want to do? Well, it turns out if we want the label to show, we'll set opaque to true. Opaque means I can see the label's background color. So we'll save that. We'll recompile. And we'll run it. And now we should see the yellow label. Now it happens the label fills up the whole space because I haven't told it to do anything else. And so we'll talk more about how we get layouts a little more sophisticated, but for now we just have one thing on the screen, and that's perfectly fine. The real lesson here is, how do we start to build something that we can make look like what we want? Okay, so we're going to come back and talk more about that another day, and we'll start building more sophisticated elements that we can have better layouts, we can have input and output and so on. But for now, I want to kind of switch gears and talk about the next assignment, because it's a little tricky, but I think you'll enjoy it once you get it done. So the next assignment doesn't require a GUI yet. It's actually pretty straightforward in that sense. But it's really useful in terms of starting to think about data. So what we're going to do next is we're going to build a card game. Now, you're not going to actually have to build a whole card game. We're just going to build this structure that allows us to manage card games. And then later on, you can make any card game you want from it. And it turns out that card games are a lot more difficult than they seem. Because there's two different kinds of data that you have to track. And neither one works like cards do in real life. And that's an important thing. The first issue is, you know, how do we keep track of a card? You know, the 3 of clubs or something, right? It turns out that's not so obvious. Now, we can use things like objects, and often you will see, if you look online, you'll see people using objects, and that's great. But it turns out that may be more complicated than you need. It turns out if we think about it carefully, one of the cleanest ways to represent a card is with a single integer. By saying, okay, there's 52 cards in a deck, I'm just going to use card numbers 0 to 51. Well, no human user really cares about cards that way. We don't say card number 13. We would say the ace of clubs or something, right? Yes, but it turns out if we think about it carefully, there's a very nice relationship between these integers that allows us to get a rank and suit out of them. What? Okay, so take a look at this pattern right here. I've put the numbers 0 through 51 in your document, and that's just our card numbers, right? But notice something interesting about how I've set them up. How many rows do we have? Well, 4 rows. Oh, how many suits are there in a deck of cards? 4. Spades, hearts, clubs, diamonds, right? Okay, that's interesting. So if there was an easy way for me to figure out what row a number was in, I could get a 0 through 3 number I could use for figuring out the suit. Okay, you get that? You may have to back up and listen to that again. But if I could figure out what row a number is in, so number 35, that's in row 0, 1, 2, for example. Number 44 is in 0, 1, 2, 3. Number 3 is in row 0, okay? That's good. If I have these numbers 0, 1, 2, 3 representing which row I'm in, I could look that up against an array kind of like this, and I could turn that into a rank: hearts, clubs, spades, diamonds. Yeah, certainly I could. Certainly I could. Okay. Now, how might you do that? Well, tell me this. What is 13 divided by 13? Well, it's 1. Good. 1, and it's an even division, so it's 1, remainder 0. What about 14 divided by 13? It's 1 and some change, or you could say 1, remainder 1. 15 divided by 13, 1, remainder 2. In fact, everything in this row, is when we divide it by 13, gives us 1 and some remainder. So if I divide any number by in this row by 13, I'll get a 1, and then if I just ignore the remainder, that'll tell me what row I'm in. Well, what about this row? If I divide any number in this row by 13, I'll get 2 and some change. If I divide any number in this row by 13, I'll get a 3 and some change. And if I divide any number in this row by 13, I'll get a 0 and some change. So an integer division of any number in the 0 to 51 range will give us what row it is in this little chart. And that could also tell us what suit we're in. So what I'm saying is this first row will make that all the hearts, and we'll make this all the clubs, and we'll make that all the spades, and we'll make that all the diamonds, or whatever. I don't remember which row is which, and it doesn't matter. Does that make sense? Yeah, that's pretty cool. Now, of course, that begs another question, right? So how do we tell what rank? Which one's the ace, and the 2, and the 3, and so on? Okay, but how about this? Okay, 13 divided by 13 is 1, of course. And what's the remainder? Well, the remainder is 0. Is that true for all of the things in this column? 26 divided by 13 is 2, remainder 0. 39 divided by 13 is 3, remainder 0. And of course, 0 divided by 13 is 0, remainder 0. Aha, remember that modulus operator? It's coming back to us. And so what we're saying now is that I can use the modulus operator to determine what column something is in. So you might be able to create a function that gives a card number and returns some sort of a string value. And in fact, my running copy of the program, don't worry about this part at the end yet, gives us this relationship. So card number 0 is the ace of hearts. Card number 1 is the 2 of hearts. In fact, the first 13 cards, 0 through 12, are all hearts. Those are all the hearts. Oh, cool. These are all the clubs. Yeah, these I think are all the, what is next? Spades. And then all the diamonds. Oh, neat. And within each row, the column indicates what it is. Now, be careful, the 1's not an ace. We don't really care about that. Ace, these are all aces. These are all 2s, 3s, 4s, 5s, 6s, and on we go till kings. Oh, that is cool. Does that make sense? So that's the first thing that freaks people out, is they're like, well, I don't understand how cards could be numbers. Right, well, this is a very clever mechanism because it allows us to think of a card simply through a number, and then what we're storing is much easier. A number is what we're going to work with in memory, and then when we want the user to think it's an actual card, we can run it through a function to say, hey, that's the 3 of clubs, or whatever. All right, so that's one thing, is how do we store the cards? The other thing we want to deal with is figuring out where the cards are. And if we're playing actual cards, now these aren't playing cards, these are just cards, but if we're playing actual cards, right, I take a bunch of cards and I shuffle them, and I have these different stacks, right? So I could have a stack over here, and a stack over here, and a stack over there, and maybe I have the decks. And what happens is these stacks change sizes because I'm moving the cards physically around. That's how you may play cards as a human, and it makes a lot of sense because in real life, this notion of a stack is a very easy thing to build. It's the most natural way to do it. But in computer memory, it isn't like that. In computer memory, we do have a thing called a stack and a related thing called a vector and an array list and so on. And these things are very, very cool. They allow us to have basically arrays that can have varying sizes and flexible adding and deletion. But the arrays that you know right now don't have that property. If we're working purely in arrays, you can't change the size of an array. And so that's problematic. So the natural way people want to write card games would be by having an array to represent the deck, and having an array to represent the player hand, and having an array to represent the computer hand, and so on. But it turns out that is really clunky and awkward, and it causes a lot of problems. So what we're going to do is we're going to look at our cards in a very different way. We are not actually going to have a hand or a deck at all. If you look at my working code, you can see what I've done here is I have instead basically a database. And my database says card number 0, you always are number 0, and you're always the ace of hearts. But what changes is you might be in the deck. Now I look at this one. Card number 1 is a 2 of hearts. Where is it? It's in the deck. Where is the 6 of hearts? Oh, the computer. I'm pretending I have a deck, a computer player, and a human player. Where's the 6 of hearts? Well, the computer owns that. Where's the 7 hearts? The deck owns that. Let's find something the player owns. 4 of clubs. That belongs to the player. So what I'm doing here is I have a single data structure which doesn't contain the deck or the computer cards or the human cards. What it contains is a database of where every card is. In regular cards, you're shuffling cards, you're moving their order around and all that. We're not doing that here. No, all we're doing is we have the same data structure and we're changing in the data structure where it really is. Hey, you belong to the computer, you belong to the player. And by default, of course, every card belongs to the deck. This may not seem like an obvious way to go, but as you watch, it'll turn out to be really useful. Now you look at the end of this game and you can see I can still get a list of all the cards that belong to the player. But what I'm doing is I'm stepping through the entire database and I'm saying, do you belong to the player? Nope, 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 nope. Oh, you belong to the player, 4 of clubs. So there's the 4 of clubs. It goes through and it only reports the cards that belong to the player. Again, this seems weird to us because as humans, we're used to only having partial knowledge of the data structure. Well, the computer program knows everything. It knows what belongs to who, and we just have to make it not cheat. Sorry, sometimes my email pops up and I need to tell it to stop. So you don't have to deal with that. You go away. Don't want to hear about the YMCA. Thank you. So that's how we're going to build this thing, is that it is going to keep track of this. Now, in real life, you wouldn't show the user the location of every card. That makes it boring. You would just show them what cards maybe they know. If you have multiple users, you would show each one only what they know. But the database knows everything. That's pretty cool and pretty crazy. So your final program is going to probably look something like this. Of course, it'll be random, so it's not exactly like this. Now let's take a look at the main code I want you to start with. So as in the last program, I'm going to give you starting code, and I won't let you change this substantially. And you're going to be tempted to, I think, because you might not agree that the way I'm telling you to do this is the best. Okay. That's fine. You can disagree with me, but darn it, I'm the teacher, so you kind of have to go with the way I'm telling you to do it. And honestly, when you see it, it'll be pretty. Let me show you some of the stuff I've given you to make this easier. First of all, I've defined the class. Now, I have created some constants and some arrays to help you out a little bit. So here's this one, num cards is 52. That's going to simplify your life a lot, having a constant here, because you're going to probably be doing a lot of array manipulation. You know, whenever you work with arrays, you normally do loops, right? And how high should the loop go? Well, typically to num cards. Okay, that's nice. And here's our first example of that. Int array card lock is a new int array of length num cards. That's going to give us 0 to 51. I'm giving you that already. Now I've got some utility arrays that are going to make your life easier when it comes to translating a card number to a card name. So suit names, there's suit name 0 is hearts, suit name 1 is clubs, spades, diamonds. Oh, that corresponds perfectly with these rows. What a coincidence. Okay. And I also have an array of ranks, 0 through 12. That corresponds beautifully with the columns. Yes, so it should be pretty easy. And I also have an array of locations, deck, player, and computer, so that when I'm talking about where something is, I can have a string in English that's easier to work with. I also have some constants here, deck, player, and comp, so that it's easier for me to keep track. I'll just put these numbers 0, 1, 2, but I can still refer to them in something that looks like English. Okay, there you go. The main method doesn't do anything new. It calls a constructor. The constructor is where you're going to get most of the clues for what you want to do. Because what do you want to do? Well, a number of things. The first thing you want to do is you want to clear the deck. All right, and what does that mean? Well, that would mean when we start the game, we want to make sure that every card belongs to the deck. So think about how you would do that. Now, whenever you're analyzing a program to figure out what you need, right, you look at a function and you say, this doesn't exist, I'm going to have to build it. You ask yourself a couple of things. What parameters does it take? None. What does it return? Nothing. So that tells us a lot. We're going to need a function called clearDeck. It won't take any parameters, and it'll return void. Okay, super. And what should it do? Well, it should go through this card lock array. That's the key to everything. Card lock is this database here. But it doesn't look like this. The actual database in memory just has the numbers 0 through 51 as the indices, and the value is just going to be a 0 if it's in the deck, a 1 if it belongs to the player, a 2 if it belongs to the computer. Now, for human consumption, I dressed it up to look prettier, but it's simply an array of integers. It's a very simple data structure. It's hard for things to go wrong. So that's what we're going to have happening there. Okay, so clearDeck is going to set every value in card lock to 0. Now we're going to do something 5 times. What are we going to do 5 times? Well, we're going to assign a card to the player, and we're going to assign a card to the computer. What does that mean? Very good question. Well, here's what it means. We're going to choose a random number, and we're going to say, let's say we picked a 7, right? And I want to put 7 in the player's hand. We would say, okay, pick a random number, 7. Oh, where is that? That's in the deck. Great. Change that. It's not in the deck anymore. Now it's in the player's hand. So somehow this assign card function is going to take as a parameter one of these numbers, 0, 1, or 2, and it's going to randomly pick a card, and it's going to assign that card, you now belong to whatever, in this case the player, in this case the computer. So since it's going to do this 5 times, by the time this whole loop is done, in a perfect world, we will have 42 cards in the deck, 5 cards in the computer hand, 5 cards in the player hand. Oh, okay. And it's not a perfect world. Something may go wrong, but you can figure that out. Now, the show hand is a utility function that does the same thing. It goes through the entire deck, but this time, it only shows the cards that belong to one player or another. And again, it takes a parameter, it seems, either the player or the computer, or we could even have it show the deck if we wanted, where it shows, it goes through the entire array, but it only displays those things that belong to the player. All right, so you know a lot of the functions you need. Now, there's one more function you probably ought to have that isn't explicitly here, and that would be that utility function that converts card number 0 to ace of hearts, and card number 39 to ace of diamonds, and so on. So you may want one more function that takes an integer and creates a string that looks like a real card name. This is perhaps the most challenging program this semester. It is not really a hard program to write, but it is a difficult program to understand. So if you're having trouble with this, my recommendation is turn off your computer, get out some paper and pencil, and make sure you understand what's really, really happening. The coding will take you about 10 minutes. The understanding could take you some hours to do. But the coding itself is not super, super difficult. Please give that a shot. It's going to take us a while to get through the GUI stuff so that you're ready to make an assignment, so I'll give you a little more time to work on this one. All right, well, thank you so much for your time. Sorry we had some communication problems, but I'm looking forward to seeing what you do on this, and we're going to have some fun building some GUIs. All right, we'll see you soon.